Welcome back to the channel. Today we are going to be installing a 12 kVA hybrid inverter from Deye and also connecting it to a 16 kilowatt hour lithium battery from Deye as well. We have about 9 panels, 9 pieces of 600 watt panels to be connected to the inverter for fast charging. You can see we have all the panels here lined up. 1, 2, 3, 4, 5, 6, 7, 8, 9 panels. Okay, so this roof is not a high roof, and we are going to be having a good time installing these panels on this roof. And so I'm going to be taking you through the entire process of this installation, from the mounting on the panels to the connections inside, because we are mostly used to connecting hybrid inverters and normal controller based inverter systems that doesn't require much of settings and all that. But this Deye inverter is a different kind of inverter. It has a lot of settings, comes with a lot of accessories, so most installers are not used to installing these kinds of inverters. So I'm going to show you, to the best of my knowledge, how you can have this inverter installed. In case you're having it in plan to do this installation with this kind of inverter in the near future, you know exactly what to do and what to expect from it. The 12 kV inverter, I'm going to show you the entire process from the panel installation at intervals. I'll make some explanations, then we'll do some videos and show you what exactly is going on at that point. So for now, I'm just going to do a capacity test for these panels. I will just do for one because we need to start work right now. I'll do a capacity test for one of the panels, then whatever we get, we just apply it to the rest of the panels. So let's see what the VOC is giving us right now. So it's about 10 minutes past 11 in the morning, and so let's see the VOC of this panel. Hey, give me the pliers. Right. So let me just cut the terminals. This 600 watts panel from Jinko Solar. You can see how the terminal is. Very sharp panel. We have about 9 panels, and we are expecting 5.4 kilowatts of energy, right, from the panels. So first of all, we are going to test the VOC and to see what we get. So right now we have red on red, then we have black on the black probe. So let's see. 44 volts, 45 volts, 46, 47. So you can be having up to 47 or 48 volts thereabouts. The 48 panel anyway. So on the nameplate we are having 52.5, then the VMP around 40 something. So that's okay. So let's just do a quick short circuit test. I don't know if you can get me a short wire, a short cable. I don't want to short circuit the terminals for too long. There was a short cable I prepared there. Just help me with the short cable. You apply to cut it so that I can just use it to do a quick test and get this done. Okay, take a plier. Just cut and peel it. So let me see what the current is giving us. Let me get an idea of what we'll have as a current. Alright, so you put it at 60 amps DC amperage. So let's see. So you put one on the positive. I'm going to short circuit it for just about 5 seconds to just get an idea of the value of the current. So let's see. It's about 4.1 amps. So I'm blocking the panel by the way. So when we take it down, it can be having up to, no, okay. Let's bring it down. Let it face the sun directly. Okay, since the sun is not really out yet, so on a norm, this panel can have up to about 9, 10, 11 amps on average. So let's just keep it aside. So we have a team of engineers already on site. They are ready for the installation of the solar panels. I already have a video on how to install solar panels using your aluminum rails. We have the aluminum rails and we have the flash band to guard against leakage on the roof. Then we also have silicone. It's a silicone gun. Then there's a silicone inside. We're also going to use it to support the flash band so that there's not going to be any leakage at all. We have the bolts, the clamps, air clamps, and so on and so forth. And again, we have screws. These are screws for the profile or the aluminum rails. You can also use nail, but for this installation, I prefer to use screw because in no distant time, we are going to install these panels from here and take to another location so that it's easy for us to remove it and take it elsewhere. So I had to use screws for this installation. And by the way, the roof is not steep, so this one would do for that. Okay, I think I've introduced everything we have here. We have nice panels of 600 watts, 6 times 954, like 5.4 kilowatts of energy we're expecting. Then we also have two solar PTZ cameras by the side. Then we have a Starlink Gen 2 to also install. As time goes on, we are going to choose that to you. This is the earth rod. We're also going to have some sort of earthing done on the inverter. We'll use that to you later on. So for now, let's just take you into the powerhouse where we are going to be mounting the inverter. So just come. So I'll show you how the inverter looks like and also the battery. Then we'll start the installation proper. So while they do the roof stuff and roof work, let's come and see. Yeah, this is the powerhouse where we are going to be connecting the inverter and the battery. So as you can see, this is 16 kilowatt lithium battery. Come close. This is how the battery looks like from there. We have the P plus the negative terminal. Then this is the breaker, the battery breaker. Let's turn it on to see how the display looks like. So you switch it on. Then you can see from the factory we have 49% the SOC, and that's fine. So when we commission the inverter, the project, I'm going to switch on the controller to charge the battery a bit more. Use the dust pan to protect from dust. Then use the mounting brackets. Then here we have the inverter. This is Deye for 12 kVA hybrid inverter. And the inverter comes with a whole lot of accessories. We have the magnetic ring for the battery, magnetic rings for the communication cable, the gen port, and also the load connection. Let me even open it so you see it properly. This is a CT current transformer. Yeah, that measures current. We want to connect to export to grid, or if you want to configure a zero export to grid, you can use this to ensure that. So then we have the communication cable or the RJ45 cord for communication between the inverter to the battery. Then is the temperature sensor for tubular batteries and all this. This is the inverter. The inverter has a data logger that uses Wi-Fi connections in order for you to be able to view the input and output parameters and everything remotely, the amount of energy that is being generated at any given time. This is a Wi-Fi data logger. I'm going to set up all this. If time permits, I'll show you a video now on how to do all this too. So that's for that. So we're about to start the installation. We have the breaker box. Then the battery came with cable, the battery cable. Then also earth cable for the battery. Then what else do we have? I think that's all. So these are changeover switch. Then we have 10 mm cable for the connection. It's a low current connection. You can use 6 mm cable, but it's just a personal preference for me. I want to use 10 mm cable for the connection of 9 panels in series to the input of the inverter. The inverter has 3 MPPT controllers inside and 6 trackers. There's 2 trackers per controller, but we are going to make use of just one. In time to come, we are going to add another battery to this battery, and we are going to get more panels to engage the other controllers and all that. So that's all. We have the cables for connection to the house, the SPDs and all that, what have you. So let's just get started with everything. We are about to start the installation. First of all, this is the battery. There are 2 ways to install the battery. You can either install it on the wall mounted like this. You put the brackets here. Then you also fix all these ones behind the battery like this and like this, up and down. Then this is the dust-proof pan to cover the top of the battery after installation has been done. Then we have a couple of screws here, but then you can also install it on the ground mounted. For ground mounted installation, use 2 fixed supports to hold the batteries on the sides. Yeah, so I think the ground support is going to work well because the battery is a bit long and I don't trust the integrity of this wall, and it's not going to be a permanent installation in the next couple of months. We're going to move it from this place, take it to another place. So it's best we just do it here so that we can easily remove it when time comes. So I'm going to use a ground mounted solution. Yeah, so I'll just fix this on the battery first. Normally, we're going to mount the inverter first because we'll mount the battery first and we'll start mounting the inverter on top. The sound from the drilling is going to sustain the batteries. So I will just fix these ones on the batteries and try to mount the inverter. Then we'll start the connections. We're not going to use this space because this space is already compacted. So I'm going to make use of that space over there. So we see when time comes. Okay, first of all, the battery is going to have this length to the ground. So it's taking it to the ground. Then we have this point right now. So the water will just take from here down straight to stop. So trunking here. Then we have the water take here up. Take from here. Yeah, so okay, as you can see, the panels are being fixed right now. So we have about 3 panels connected already. It's going to be a series connection all through. So we have 2 steps. First step is going to carry 5 panels. So we are starting from here. This 1, 2, 3. We have 2 more panels over there. Then we continue the series on the other step. Then we connect the remaining 4 panels. Then the output is going to be there. So either the positive or the negative is going to enter inside. So I'll go inside on the roof and connect the 10 mm cable to the inverter as the solar input. So we have the main panels done there. So let's go back to the powerhouse to do the main connection for the inverter. See, the screws is very solid. You don't need to worry. It's a 3-inch screw. You can see we also applied the silicone to make it firm and leak proof. So you can see it's very easy for you to unmount this profiles. Just use your screw machine and lose it out. So that's it. We mounted the inverter and the battery, so we mount the breaker box. In everything we are mounting, we are using screws, fishers or wall plugs. So it's not a power net installation. If it's to be a power net installation, you can use nails. So let's screw this one in. We can arrange breakers, protective devices. We have the AC automatic voltage regulator, though we are not going to use grid to charge this inverter. Then this pulse meter, 16 amps DC breaker. Current we're expecting from the solar panels, it's not going to be more than 13 amps, 15 amps. So if you're having surges, that's why the 16 amps is there to cater for those lithium minor surges. So I'm trying to set up the trunking, help us be able to manage the cables and make sure the work is as neat as possible. And these grid inputs to the inverter. Join inputs, no. And load here. So then this battery cable, very big hole in that. Okay, so that's it. Alright. These are the solar panels. 9 solar panels of 600 watts each, connected to the inverter. And so the only thing left now for us to do is to do the inverter connections, the settings, and also to connect the earth rod and the earth wire. So that's all that is left for us to do right now. I'm going to take you through everything. Solar panels are well fixed and everything is looking fine at the moment. Yeah, we're going to commission it if there's still time. I'm going to show you everything that is involved, all the whole process. So just thank you very much. Make sure you click the like button and also subscribe button. And so we're going to be giving you more of these kind of installation updates and tips on how to do installations like this. So essentially the inverter has 3 MPPT controllers.
The reason is that it allows you to be able to place panels on different sides of the roof, on roofs where you have different cuts and everything and bends. You can place panels on the south, west to face different directions and connect to different inputs of the inverter for the controllers, either the MPPT 1, 2, or 3, tracker 1, tracker 2, and so on and so forth. So that's it's why we have that. So let's check other stuff. So this is the earthing. So we have the earth rod here. Then this is the earth wire. We are going to take this earth wire and directly to the surge protecting device. There's an earth terminal there, so we add the surge protector to protect the inverter from lightning strikes. So we have an earth rod here. We're just going to connect the wire to the earth rod. That's all. So it's need to go to that'll be all. It's into the ground. Battery cable that came with it is very long, so you also have to manage it. I don't want to cut it because I don't have the tools to reconnect the cable up. So we are going to just try to pack the cable to one side and just do the connection of that. So I'll pack them to one side. Then I'll bring it here and do the connection like this. So the negative will go that way. Possibly come here. Then also the BMS communication. You have to use the cable. Yeah. If it's the same brand, you have to use the communication cable. So once the cable is there, all the voltage, charge, and all these things are connected. And with the same brand, without the cable, you have to set it on and using user-defined mode. So essentially, you have to connect it through one of all these plugs here. So this command. So let's just command. Yes. So this is where you connect the communication cable. Yeah. This BMS. This one is for meter to connect to your smart meter. Using Modbus connectivity, then these two are the parallel connection ports. You have one and one inverter to connect. Yes. Solid. It's not to adjust the length, to reduce the noise, to make sure the signal to the battery is from the inverter to the battery is strong and is free of noise. So there's also call for the load. The load side and also the battery. For the battery is too full. This is the core for the battery, but the battery cable is not going to go through this one. So I'm going to leave that one. Because we're supposed to wrap it around that one 2 times. So it's not possible to wrap this one once on this and get to this button to connect it. So I'm going to skip this. Just connect it like that. So this is the 3rd one, then this is the 4th one. So take it again. 4th time. Okay. So do that. So look at this, chop it in here. Connect. So then this one will go into the battery. So chop it. There's this device that came with this inverter. This is a coil transformer. It measures current, and you can clamp it on the AC side or the grid side, the load side or the grid side of the inverter. to measure the current that goes into the inverter or the current that goes out of the inverter. Now this inverter has a feature called export to grid, where you can export power to the grid, you can sell power to the grid. But in this case, we don't want to use that feature, so we need to use the CT to block that feature, because by default the inverter sends power to the grid by default. And so I'm going to make sure you connect the CT to the input side, the positive side of the input. So here's the input. Connect the input so that will connect the positive side. Then make sure this arrow faces up the direction of the current, where the current is supposed to flow to. So the load is going to flow to the inverter from the grid. It's going to flow out of the inverter. So that's that. Then the wire, I'm going to connect it to 5 and 6 in this address bus here. So go to 5 and 6, use a flat screwdriver to open, then connect to 5 and 6. The bus address 1, 2, 3, 4, 5. So you open 5. Connect to 5. Connect the white to 5. That's it. Then the black to 6. So when you do this, the CT is going to block current from going the other way around from the inverter to the grid. Okay, so now connection is.
So you can't connect to any other place, you say 5 and 6.
5 and 6, yes. Yeah.
Cool.
That when you want to sell power to the grid, you want to send power to the grid, you use 3 and 4. But if you want 0 exports to the grid, you use 5 and 6. So that's it for that. Then again, the inverter also came with a temperature, remote temperature sensor, but we're not going to be making use of that because essentially this one is used majorly for solar batteries that doesn't have an inbuilt temperature sensor, so regulate the temperature when it is charging or when it is discharging. So for lithium battery, this battery is very complex, but it has a temperature sensor already inside, so you don't need to connect an extra temperature sensor. So otherwise, if you have a tubular battery, you can connect to the B plus and B minus. Yeah, you check, you see B plus and minus. And this connector you connect it. But I don't want to make use of this because you're using a lithium battery, so keep this on the side. So that's it. Alright, so plug it in this manner. Sure it is well connected. You have to be very careful so you don't break it. It's okay. It has been connected. Actually, yesterday something happened. While we were trying to connect the PV to the PV inputs on this inverter, I noticed that the PV inputs, because there are 6 pairs of PV inputs. I noticed that there are no screws where you can connect and just easily screw back and lock. So I was trying to use these pegs. I saw that these pegs could easily open like this and lock. So I thought that these pegs were actually the key to connecting the wires inside. But I opened it and I tried to fix the wires inside, even the smallest of wires. These pegs couldn't hold them. So it was really a big issue for us yesterday because I've not actually seen this kind of stuff. It's the first time I'm experiencing this. So I just decided to do a video. I had to call the engineer yesterday and he told me how to go about it. So I decided to just add it to the video in case you want to install and you get to this point so that you don't be confused. All you need to do, these pegs, I was trying to pull it up. I didn't really know what to expect because I don't want to destroy anything on the inverter. So I was trying to be very careful with it as well. So it can go all the way up like this. So there's a spring inside, there's a spring mechanism that can allow the peg to go up for the holes inside to be opened completely. So when the hole is completely open, you can put the wires and it will enter. When you take it down, it will lock. You can see that I've already locked the negative side. So I'm also going to do the same for the positive side. So that will be it. So when I connect the PV wire to the inverter, I don't have any other thing to connect to the inverter again. I will just simply connect the one coming from the panels to this breaker and I'm done. Then I will be able to test the inverter and show you other settings that you need to know about the inverter. So let's see. I've connected the PV input, so it's very firm and tight now. You need to confirm if it can easily pull out. So it's very firm. So let me just quickly take you through everything that is in here, that is going on right here, and what you need to know and what is important for you to connect. Now, the thing about this inverter is that it has many features, but the truth of the matter is that most of those features, we cannot actually use them here in our country, because most of those features, they are actually for countries that have strict wiring regulations. You understand? So they have to follow some specific standards. So what you need to do, the most thing that is important when you get this inverter, this is your battery, the battery connectors here. So the battery terminals connect the battery positive and negative. Then the communication cable, this our J45 cord, connects from the inverter to the battery to this port PCS. That's 2. Then the PV inputs. Let me explain the PV inputs. You can see we have 2, 4, 6, 8, 10, 12 inputs here. Now these 12 inputs, this is how it works. There are 3 MPPT controllers here. We have PV1, PV2, PV3, then PV1 positive. So from these 4, we have positive for PV1. Now these 4 inputs are for PV1. The other 4 are for PV2. The last 4 are for PV3. Now PV1 has 2 trackers, 2 MPPT trackers. So this is the first tracker. For the positive side, this is number 1, first tracker. Then second tracker for positive. Then first tracker for negative. Second tracker for negative. So I'm using the first tracker and the first MPPT to connect my 9 panels. So all you need to do is just to put this one here and hook the other one here. So if you want to connect for PV2, use this other 4. PV3, use this other 4. Now this first tracker, you can connect if you want to share it. Maybe you want to put some panels on another side of the roof instead of putting everything on one and trying to put some, because sometimes one thing about series connection is that you need to place all the panels in one direction. Yeah, you cannot put some at the back and some at the front. But with these trackers, you can actually separate the panels and put some on one of the trackers and some other of the trackers. So that's why this thing is very important. So we have 10 panels. I want to put some at the front and some at the back. I can put 5 on this one, then take another 5, put on the other side, then use a separate cable to send it down for PV1. Then same thing for PV2 and for PV3. That's the importance of all these trackers and everything about that. Then these 3 communication ports here. This one is to connect to a smart meter. You don't need that. Then these 2 for parallel communication. You want to connect other inverters in parallel. Use these 2. Then this one is the CT, current transformer. You don't want to export to load. You are going to connect it in such a way that this arrow faces up, meaning the current is going to only flow towards this one direction, towards the inverter. Yeah, from the grid. You don't want to export to the grid. So you use this, then you switch on the 0 export feature on the inverter. I'm going to show you that shortly. Then that's it. Then the CT, you connect it on this address bus, connect to 5 and 6. 5 and 6. That's it. For other features like exporting to grid, you can connect 3 and 4 and all that. You can check the manual for more reference about that. Then again, we have the gen port. This is the grid input. This is the gen. This is the load. Now, what's the difference between the grid and the gen? This gen is for you to connect a generator, a diesel generator, to the inverter. Then this one is for you to connect the grid. Because most times, generator input is not always stable in terms of the frequency. So this particular port is optimized to work with that instability from the generator. But most times, there are times where even the generator is more stable than the grid. But let's just leave it at that. So this one is designed in such a way that you don't have to start using one input for both the gen and grid. Because some inverters, they don't accept generators that fluctuate in frequency and voltage. So when you connect those kind of inverters, when you connect inputs to those inverters from the generator side, it won't charge. But when you switch over to the NEPA side, it will charge. But for this one, it has a separate generator inputs where you can optimize the inputs from the generator and make sure it charges the battery. Then this is the load, the live, earth, and neutral. Then lastly, we have where you can connect data logger under. If you want to be able to monitor, this is data logger. If you want to be able to monitor, is optional, it's not compulsory. If you want to be able to monitor the energy generation at any point in time remotely, yeah, you can connect this and do the setup on your phone through the mobile application. Then that will be active. So that's all you need to know about everything to connect inside. Okay, testing the open circuit voltage before we connect to the inverter. We're having 441 volts. So this is the input that's going to go into the controller. The maximum voltage is 500. So I've connected everything, all the breakers. I'm not going to use the grid to charge these batteries with the inverter. I'm not going to enable grid charging for obvious reasons. The grid supply to this place is not really that good, and also even the generator they have here is not really too good. But I've connected everything to this changeover, and there's need for them to use generator. They just have to bring this stuff down. If they want to use the inverter, they take this one up. But for charging the batteries through the inverter, for grid charging, I don't want to enable that. So when I close all these things, I'm going to test, switch on the battery, switch on the inverter, and test to see how the inverter is going to charge the battery through the panels. Then we see the amount of energy we'll be able to generate. All right, so thank you very much, and welcome back. And I just want to let you know that we finally installed the Deye 12 kV inverter. As you can see, this is the 12 kV inverter and the 16 kilowatt hour lithium battery from Deye. This system is up and running at the moment, and you can see everything is working fine. Let me take you to where we have the protective breakers. They are right here. This is the changeover switch, and right now the inverter is up and running, it's working. When you want to go solar and you're looking for premium quality, you don't have to look any further. This is one of the best systems that you can opt for if you want to do solar. Now, this is a low voltage system. You can also have high voltage systems. For instance, you can have up to 120 volts, but this one is a low voltage inverter, now 48 volts, and a low voltage battery, 48 volts, for household use. Now, let me take you through some of the features of this inverter. Now you can see that the inverter has a switch. The inverter has a DC switch. It's like a breaker. It has the off and on button here. The battery has a breaker, so there was no need for us to install a separate breaker for the battery. Then we also have the communication cable here that enables the battery to read that the inverter is being connected and to see that it is Deye that is being connected to the battery. In a couple of minutes, I'm going to show you the screen, what's going on inside of the inverter to see what we are generating from the sun. So we have about 9 panels connected in series to the first controller of this inverter, because this inverter has 3 controllers in total. It has 3 MPPT controllers and 6 trackers, 2 trackers per controller. We use only one side of the controller, which is the one tracker, because connected all the 9 panels on one side of the roof. I'm going to quickly show you some of the settings that you can do for this inverter, the basic settings that you need to know to ensure that your inverter is working and running perfectly well. So let me show you. Okay, right now, this is how the inverter works. When the inverter has worked for some time, it goes to idle mode. When it goes to idle mode, the screen turns off. But you can wake it up by tapping on the screen. It's a touch screen, so you can see some of the details on the screen. Now, right now, it is charging from the solar panels. Now you can read right off from here the amount of energy that is being pulled from the solar panels at the moment. So we can tap it to get more insight. When you tap, you can see that it's 1170 watts at the moment. We have 370 volts as the voltage going into this inverter. Then the charging current is about 0.1 amps. So this is the MPPT 1168 watts. So today we've generated a total of 2.3 kilowatt hour of energy today. Yeah, we just turned this system about 2 hours ago. We turned it on about 2 hours ago. And so everything is looking good. So you can tap on energy to see the energy graph. At this point, this 3 o'clock, we were able to generate the highest amount of energy. That's 80%. Yeah, so the highest we have 3,000 watts here. So we generated about 80% of the total amount of power that has been generated so far at 3 o'clock, past 3. Okay, so that is that. So you can check for a day, you can check for months, monthly graph, check for the year, check for total. Let's go down. Okay, go down, you can see other details for other days. So let's go back. Then also, you want to check what's going on in the battery. Tap on the battery. So right now, the SOC state of charge is 63%, as you can see right here. Then we have the battery voltage is 53.71 volts. Battery current 20.1 amp. Then the power 1089 watts. Temperature is 29 degrees Celsius. Now you don't need to worry because the communication is very, very seamless between the battery and the inverter. the inverter has been able to sense that it's Deye battery that is connected to it. So let's check the lithium BMS. You can see other details on the screen. We have 53 volts, 20 amps as the battery current. You can see the battery charge voltage. You can see the charge current limit and discharge current limit. So right now we are not using anything right now because we are still on generator. We just power this system on and we need it to charge to some extent before we can start to use it. Right now it's 62% on the battery. Now it's interesting to note that the battery doesn't have a counter in the case that it is charging, like the normal kind of batteries we normally have. You see something moving up and down to indicate that it's charging. So, but that is fine. It's 62%. When the inverter charges, the battery updates the state of charge, and that's fine. The battery is a very heavy one. Yeah, so let's check some parameters of the battery. So we have the nominal capacity as 314 amps. Then we have the nominal energy, 16 kilowatt hour, 51 volts, 160 amps as the discharge and charge current. Okay, so that's it. That's fine. So let me take you through some of the settings on the inverter so that you can understand a bit more what this inverter can do and how to get it up and running after installation. So let's check the battery settings first of all. Now, the first thing is when you turn on the inverter doesn't supply until you tap on lithium, tap the particular battery you're using. So if you're using lithium battery, just tap on lithium, then you set the capacity by yourself. It's editable. Just tap with your finger, then use the up or down button to set it. So we already set the battery capacity 314 ampere hour like we saw earlier, 160 amps, 160 amps. So activate battery. When you tap on activate battery, the battery activates. So that is for that. So you can check. This is start battery settings 30%, gen signal, grid charge. I want to turn off grid charge. I don't want to use grid to charge. So you turn it off. Then just check other settings. Then these are lithium mode. Is on lithium mode. This tells us the communication protocol. You can see Deye here. It has been able to sense that it is the battery that is connected to it. So that's there. Then shut down 20%. Let me put it at okay. 20% is okay. Well, let me put it at 10%. Let me put it at 10%. So let me put it at 10% down. So the battery will shut down when it's at 10%. So this low battery is for the grid charging. Then we start for grid charging. So we didn't connect grid to it. So can leave it like that. So that's all for this. Then save it by tapping on this arrow. That's save. Then basic settings, the time, the month, and the day. Make sure the time is correct so that when you connect it to your when you connect it to the app using the device that is here, yeah, the data logger, the parameters you see will match with the time, the exact time in real time. We have real time figures, so that is there. So battery settings, English. So that's all for the basic settings. Then system work mode. So we are not exporting to the grid, so just tap on 0 export to city. So that is there. So this is the maximum solar power you can sell. You don't need that. Then the energy pattern, make sure you click on load first. Very important. Grid peak shaving, the amount of energy that can be accepted from the grid. So we don't need all that. Just come down to check. Then also make sure you click on time of use when you get to this point. So but for grid charge and gen, you don't tap on this one, just leave it like that. In time of use, click on time of use. When you come to this page, you see battery percent as 80%. So when it discharges to 80%, that's when it tells you that it's low. So you have to reduce it to 35%. You know, we saw 35% earlier on the grid side. So just reduce to 35%, and that's all. Then system work mode, make sure everything is checked from Monday to Sunday. So if anyone is not checked, if you turn off Monday, on Monday this system will not supply any power to the house on Monday. So make sure everything is on. So that's there. You click on enter. Then gen port use, we don't need anything here. We just leave everything here as default. Everything here as default. Then what else again? Advanced function, we don't really need anything here. There's nothing that is important here. This is for parallel. You want to connect more inverters, multiple inverters in parallel. So this is where the settings are. Slave, you connect, set which one is the master, which one is the slave, and all that. So we don't need that. Then this ATS, we don't need that. Just leave everything at default. What else? Which other settings? So these generator settings, we don't need anything here. Just go back. Grid settings, nothing. Okay. For grid settings, grid frequency 50 Hz. Then single phase. This is a single phase inverter. In case you are connecting grid to charge, you can set the low voltage and the high voltage. So this is the highest voltage, 263 volts, quite high. So we don't need to edit anything here since we're not using a grid to charge. So that is it. Right now, it's safe to say we are done with this installation and we don't have anything to worry about again. Just enjoy your system and have the best of quality of life, enjoying your solar system. Okay, so thank you very much. Thank you for watching this video. I really want to appreciate you for taking your time out to support me on my channel, watching my videos, and also support me. So thank you very much. I'll make sure I try my best possible to bring more of these kind of videos to help you, installers, intending installers, end users, to understand their system more and to be able to have an insight on how these things work. In case you have it in mind to do any of this kind of installation in future, you should know, you should have options and you know what is best for you and to make the right decision. Make sure you click the like button, also click the subscribe button, and be sure that we are going to have more and more of these kind of videos soon. So thank you very much. Yeah, peace.